Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it. Hook. This one question cost more students' marks than any other on last year's papers. A sketching question where students plotted 3 points but forgot to check the end behaviour. That tiny missing sentence lost half a mark, then another, then panic. Stick with me for 12 minutes and you'll have a short, repeatable routine you can use under pressure to stop that from happening. Sound familiar? I did a past paper and my sketch looked fine until the examiner crossed it out because I hadn't labelled the asymptote. Here's the promise. A 4-step routine. Identify shape, find key points, check turning points and asymptotes, then confirm end behaviour, and a 1-line script you can write on any exam answer to collect method marks, even if your pencil slips. Let's work through this step by step. Concept. Step 1. Identify the type and shape. Is it a quadratic, cubic, or reciprocal? Each family has a signature shape. Quadratics are parabolas, U-shaped if the leading coefficient is positive, upside down if negative. Cubics have an S-shape and can cross the x-axis up to 3 times. Reciprocal graphs look like 2 opposite curves with vertical and horizontal asymptotes. Say that sentence in your head when you read the question. Quadratic, parabola, cubic, S, reciprocal, 2 branches. So the first thing is naming the family. That already narrows what the sketch should look like. Exactly. Step 2. Find and plot key points. For quadratics, that's the vertex and x-intercepts, or y-intercept. For cubics, factorise if you can to find real roots, and check 1 extra point to control the curve between roots. For reciprocals of the form y equals 1 over x minus a plus b, identify the vertical asymptote x equals a and horizontal asymptote y equals b. Then plot 1 point on each branch to fix the position. Always label exact values. Don't write about unless the question asks for approximations. The examiner wants exactness where possible. Step 3. Turning points. For a quadratic, you can complete the square to get the vertex exactly. If the quadratic is y equals ax squared plus bx plus c, write the vertex as minus b over 2a, value, or complete the square to show the method. For a cubic, differentiate is not required at GCSE Higher. Instead use factorisation or symmetry, or find stationary points by noting where the derivative equals 0 if the question explicitly asks. If not, give the coordinates of turning points you can calculate easily. Writing the calculation, vertex at x equals minus b over 2a, is the sort of method line that earns you method marks. Wait, should I always show the algebra for the vertex, even if I can see it by eye? Yes, write the short method, xv equals minus b over 2a, so xv equals ... yv equals ... That's a clear method line. Don't skip it. Step 4 is end behaviour and asymptotes. For polynomials, say how the curve behaves as x tends to plus or minus infinity. As x tends to infinity, y tends to infinity, for a positive leading coefficient quadratic. As x tends to plus or minus infinity, y tends to plus or minus infinity, for odd degree cubics, matching signs. For reciprocals, state the vertical and horizontal asymptotes explicitly. Vertical asymptote x equals a, horizontal asymptote y equals b. These 1-line statements are gold when an examiner ticks boxes. Now, let's do 2 short worked examples, one quadratic and one reciprocal, and I'll narrate exactly what to write, so your answer looks examiner ready. Sketch y equals 2x squared minus 8x plus 6. Step 1. Identify. Quadratic, upward parabola, because a equals 2 greater than 0. Write quadratic, upward parabola. Step 2. Key points. Y-intercept at x equals 0 gives y equals 6, so plot 0, 6. Find x-intercept. Solve 2x squared minus 8x plus 6 equals 0. Divide by 2 gives x squared minus 4x plus 3 equals 0. X minus 1, x minus 3 equals 0. So roots at x equals 1 and x equals 3.
Write each step briefly on your answer sheet to show method. So I write the factorization and circle the x-intercepts. That shows I didn't guess them.
Good. Step 3. Vertex. Use xv equals minus b over 2a equals 8 over 4 equals 2. Substitute x equals 2 into the equation. Y equals 2 times 4 minus 16 plus 6 equals 8 minus 16 plus 6 equals minus 2. So the vertex is 2 minus 2. Write vertex at 2 minus 2 via xv equals minus b over 2a. Step 4. End behaviour. Since a greater than 0, as x approaches plus or minus infinity, y approaches infinity. Put that as a one-line comment at the bottom of your sketch. Now join the points with a smooth parabola, label the vertex and intercepts, and your answer reads exactly like an examiner-ready script.
Example 2. Sketch y equals 1 over x minus 2 plus 3. Step 1. Identify. Reciprocal with shifts. Step 2. Asymptotes. Vertical asymptote at x equals 2, horizontal asymptote y equals 3. Write those two lines clearly. Step 3. Plot 1 point on each branch. Pick x equals 3 equals y equals 1 over 1 plus 3 equals 4, so plot 3, 4. Pick x equals 1 equals y equals 1 over minus 1 plus 3 equals 2, so plot 1, 2. Step 4. Sketch branches approaching the asymptotes. Label x equals 2 and y equals 3 and write asymptotes x equals 2, y equals 3. The marker sees the correct asymptotes and labelled points and awards marks even if your curves are hand-drawn.
I've lost marks before because I drew the branches on the wrong side of the vertical asymptote. These 2 test points would catch that, right?
Exactly. Little checks like that save marks. Now, the exam technique section. What are the marks actually for? In typical higher tier sketching questions, you'll see 2 to 4 marks. 1 mark, M1, for the correct general shape. 1 mark for correct key points or intercepts. 1 mark for correct asymptotes or vertex coordinates. An accuracy mark, A1, for a neat, accurately drawn curve or exact values. So how do you maximise marks? Write the methodines, name the shape, show short calculations for intercepts or vertex, state asymptotes, then label points clearly. Even if your final curve is messy, those method lines can win you 2 to 3 marks.
Common pitfalls: forgetting to label axes or units, writing approximate decimals when exact values are easy, and not showing your working for the vertex. The fix? Use this labelling script on the paper. 1. Type quadratic, cubic, reciprocal. 2. Key points. List calculations and coordinates. 3. Asymptotes and end behaviour. One-line statement. 4. Join points smoothly. Write those phrases. Examiners love to see method.
That labelling script sounds like something I can copy straight into the answer box. It's easier than trying to remember everything when I'm nervous.
Quick win. A 60-second sketch checklist to memorise. Say this out loud before you start any sketch. Type, points, turning/vertex, asymptotes, end behaviour, check 1 point. That's 6 words that trigger the full routine. Then do a one-line substitution check. Plug 1 plotted x back into the equation and confirm the y value. That catches sign errors in 90% of cases.
Live mini-example. Very quickly sketch y equals x cubed minus 3x squared minus x plus 3. Step 1. Cubic, S-shape. Step 2. Try factorising. Group, x squared times x minus 3 minus 1 times x minus 3 equals x minus 3 times x squared minus 1 equals x minus 3 times x minus 1 times x plus 1. So roots at x equals minus 1, 1, 3. Write that. Step 3. Plot those 3 x-intercepts. Pick a midpoint, say x equals 0, gives y equals 3, so plot 0, 3 to control the curve. Step 4. End behaviour. As x tends to infinity, y tends to infinity. As x tends to minus infinity, y tends to minus infinity, because it's an odd degree with positive leading coefficient. Label everything. You have given the examiner all the method lines they need. That's your exam-ready cubic in under 60 seconds.
Write the factorisation, mark the intercepts, add 1 checkpoint, and state the end behaviour. I can do that.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and downloadable checklists at jcacademyonline.co.uk. Stay curious.
Final signature. Trust the process and nail that exam.